Yes. At the back, BAC. We roar. And about science. Science that is associated with understanding that will bring application that will lead to problem solving. Electric field intensity as we move on and calculate the electric field intensity at a point C, when you have charges of plus 5 microcoulombs and minus 3 microcoulombs at those places. In other words, the question is saying that just here, that charges of minus 5 microcoulombs, actually plus, and minus 3 microcoulombs are placed on the vertices of a triangle situated in the air, as shown. By the way, you have to remember why we normally say it is situated in air, because it has to bring in the other constant, which comes out to be 9 exponent 9, which is only possible when they are in air or when they are in vacuum. So calculate the electric field intensity at point C. This has come along the principle of superposition of electric forces. So how do we handle this? I can redraw another diagram, or I can first write from here. So if I bring one positive charge here, will it be attracted here or it will be repelled? If I try to bring it, this is positive, so it will repel it. So we shall have it moving along that direction. So that is the force. Force due to this charge of 5, or force due to the charge at A. Oh, this is positive, this is negative. The brother and the sister, they always like each other so much. So this one, if I try to make it go there, it will actually go. So the force, this is force due to a charge at B. You realize it is resembling what we did in forces. So we shall need to calculate the angle, determine the angle. So there is a certain angle here that we actually have to determine before. So we need to know this angle and that angle. So if I can draw here a line, if I can draw a line there, so that this is 20, so this will remain. This will be 10, then this is 20. Then if this angle is theta, then I can have cos theta adjacent, which is 10 out of 20, which will actually give me theta equals cos inverse over half, and that should be giving me 60 degrees. So this angle is 60, and this will also be 60. This equal to this will actually give us these two angles equal. So this angle is 60 and that one is 60. I'm going to put all these ones in the new diagram so that they can be viewed very well. So we have this point, which I can just draw like this. Then I show we have this force at an angle of 60 degrees here, and we have another one there. Also there is an angle of 60 degrees. So we need to calculate those two forces. We need to calculate the two forces. So which is now this one, F due to A. A is, of course, remember our formula, 9 exponent 9. Then the one of A is 5 exponent negative 6. Then out of the distance of separation is 20, so that is 0.2 squared. And when I do that one on the calculator, I should be able to get 1.125 exponent 6. 1.125 exponent 6. And then when I calculate f due to this, which goes in this direction, it should give me 9 exponent 9. Then this one is 3 exponent -6. Then the distance is the same, 0.2 squared. And when I calculate that one, it should be able to give me 6.75 exponent 5 Newton per Coulomb, Newton per Coulomb. And therefore, you can see this was the one on B, so this is 6.75 exponent 5. Then this one is 1.125 exponent 6. So we got to resolve these two. We got to resolve, which I also want to read for you. Can you do resolving? You get for me the horizontal components and the vertical components. Do it. I know you can do. I know you have the capacity. Please do get the horizontal and the vertical components. Then we shall move on. You have a minute. Thank you. Go ahead, go ahead. Yes, I know. You are getting it. Don't be like it's not correct. Remember to have your calculator in degrees. That answer was brought out by it being left in radians or some other setting. Yes. Thank you. I knew you would do it, and you have actually done it. So finally, when we get our electric in X and in Y, the one in X will be 1.125 exponent 6 cos this angle 60 degrees plus 6.75 exponent 5 cos of this angle, the whole of that. Remember, which is 300 degrees, and then the one in Y would be 1.125 exponent 6 sin 60 degrees plus 1.125 exponent 5 sin 300 degrees. And when you do those ones on the calculator, this one should give you 9 exponent 5 Newton per Coulomb, and this one should give you 3.8971 exponent 5 Newton per Coulomb. So we have now got the vertical and the horizontal components of the electric field intensity. Now we can represent them. They are both positives, so we have this and that, where this is the horizontal is 9 exponent 5, and then this is 3.8971 exponent 5. So when I do this one, the resultant will be the square root of 9 exponent 5 squared plus 3.8971 exponent 5 squared, and that one should give you 9.81 exponent 5. 9.81 5 Newton per Coulomb at an angle. At an angle alpha, which is an inverse of this out of this, that is 3.8971 exponent 5 out of 9 exponent 5, and when you do that one, it should give you 23.4 degrees, and that angle is above the positive horizontal axis. The angle is above the positive horizontal axis. So that's how we are able to get our resultant electric field intensity at a position C. It's as simple as you get a positive charge of 1 coulomb, you place it at that point, and then you calculate a force on it due to this, okay? When I try to bring it here, it is positive, it is repelled, it has to go in that direction. So the force is this. When I try to bring it this side, they are opposite, it will be attracted, the force will come like this one. Therefore, you see, the diagram is like that. Then I am able to get this angle because this is 20. If I get an angle of 90 here, this will be 10 and 20. When I use them, I am able to get this angle theta. This being right angle, I was able to get theta at 60 degrees. Found out that this angle is equal to this, is equal to this, is equal to that. Therefore, this is 60, this is 60. Then you do the resolving. You have got F on A, F due to A and F due. Actually, they are the electric field intensities, much as they are also forces. It is a force. Okay? So when you resolve, remember resolving, if you have an issue, notify us and we help you on that so that in the other mathematics group. So you finally reach here, and finally you are able to get the resultant electric field intensity, which is 9.81 exponent 5. Never forget the standard units, and never forget to give us the direction, which in this case is given by the angle. Now this is yours to do, just for trial. Yes, I want you to do this. Very simple. This is 0.1. This is 0.05. This is 5 centimeters. 5 centimeters. 5 centimeters. Yes. These are also situated in air for that particular calculation. They are also situated in air. Calculate the resultant electric field intensity at a point M. The resultant electric field intensity at a point M. Calculate it. Don't forget to encourage your friends to read hard, because knowledge is power. Understanding is conquering.